Hello everyone. In this video, we will continue our uh, explanation about SEH, but this time, which is structure exception handling, just in case you missed the previous video. But this time, what we will be doing is, last time we had this security check disabled. So this time we will be enabling it, okay, and compiling the application again. So this time the goal is to bypass the security guard. Okay, I already wrote on my account what security guard is, but just in case, let's open the Microsoft's web page and take a look at it quickly. So stack guard or stack cookies, they get enabled with the GS flag. Okay, so once you apply this, uh, there will be like a security cookie added to the stack, and that way what happens is the system, before it unwinds a frame and goes back to the previous frame, so let's say a function a a function in a program does a call to another, let's say, function, or the program does a call to a function. Before the program goes back and let me just repeat that again. You have a program, it does a call to some function. So before the function ends and goes back to where it started, the unwind process will check if the security cookie or security data which was added onto the stack has been overwritten or not. If it has, or it has been modified, I mean, if it has, then it means the stack has been corrupted. So the application will uh, uh, will get terminated. Okay, so the application will get terminated if the security cookie is gonna be modified. Okay, so we will check this all in this video. We'll learn a little bit about the how to bypass this using SEH. I'm also gonna like show at least the security cookie, debug that using the debugger, look at it in memory, use the debugger and see how it's being checked and how the application will crash once it sees that the value has been modified, and so on and so forth. So there are a couple of things we will be learning in this video. The idea is not really just about exploitation, but also to learn more about uh, these mitigation techniques. So this is by the way, a compiler mitigation technique. So it's a technique to mitigate exploits added by a compiler. As you saw, we applied it using the compiler itself. Now all we need to do is compile, which I already did. So we now have a new application, by the way. So if we use our previous, like just one important thing, if we use our previous code, which we coded last time in the previous video, to exploit the same application, because I left it the same name, it will not work because the stack is now different and the offsets, all of these have changed. So if I run this, you'll see that this is not going to work. Okay, so the buffer length is all correct and the application started, but it will not work and it will terminate. Why? Because the stack guard probably prevented that from happening, and all of these offsets again have been modified. So what we are going to do now is let's create a copy of this, or even let's see, what was this one, and start from there, because we'll need to modify. Yeah, let's use this one. So let's do a copy. Gonna call it bypass 1. So this is going to be a little bit a long journey, so please stay focused. If you have coffee, tea, whatever you like to drink, make sure those are available beside you. So what I'm going to do now is I will, let's say, yeah, let's disable this, because at the beginning I want to find the new offset. Okay, so I'm going to do buff equal, let's say, pattern. Yep, and let's do a pattern here equals a multiplied by 1000. And I just want to run immunity and create a pattern. Or actually, let's wait a minute. We already have one here. So let me just use this. This one was done from the previous video. So let's just use that. So if you don't know how to create a pattern, please just go back to the previous video and watch that. This is very simple using immunity debugger and Mona. And yeah, thanks to Mona, we can do that. So if we run the code now, because I want to adjust the offset, bring some coffee. And now if we run the application, so if we run the application, an exception happened. Now, as you can see here, look, as you can see here, the pointer to our next SEH has been overwritten. The handler has been overwritten as well. If we go down here, we can't even find the end of the chain of our exception handlers. Why? Because everything has been overwritten. You can also see this in SEH chain, like we did probably last time. So we can see that our SEH chain, which is this, record smashed at offset 28. So by the way, keep this one in mind. This is telling you the offset, but let's see how we are going to actually find the offset. So if we now hit, let's say, Shift F9, so the EIP got overwritten with this value, right? So let's copy it and now use Mona again. Mona pattern offset, okay, and give it the value. So we will see that it's found at offset position 32. Great. But keep in mind the next, because remember, the SEH record, or let's say the record for the structure exception handler, are 2 4 bytes. The first 4 byte points to the next one, the next SEH record, and the next 4 bytes actually points to the handler itself. So at offset, so this one is telling you the pattern, the offset is 32, which means that the next SEH is at offset 28. So this was also another way we can find the offset, but it's probably just in this case. Okay, so keep that in mind. Now we have 32. Let's go modify our code and let's go here. So we have, so this is bypass 1, gonna follow the same thing we are used to. Bypass 1, bypass 2, and so on and so forth. So let's call it this way. And now let's do A's multiplied by 32, right? Or we can just immediately do 28 and then, and actually no, we could just go now immediately to this and say 28. Yeah, why, let's just stop using this one. We don't need it anymore. Okay, and let's continue. So, or actually, let me do one thing. Sorry, let me do one thing. Let's see the stack guard. Yeah, let's see the stack guard here. So instead of 28, let's do like 50 to overwrite this with 50 and see what's gonna happen. So I hope we managed to overwrite the cookies as well with this option. So now if we look at the chain, Mona SEH chain, okay, we can see the default for the system, all good. So now if we execute our application, okay, and then let's execute our application, see what's gonna happen. I'm jumping over most of them. I just want to see. So our pointer to next SEH now got loaded, by the way. If we run this again, we should be able to see it because it got now loaded, added to the stack frame, added to the stack, I mean. And if we go back, I probably, because I'm using F8, so I probably jumped over the entry where it got added to the stack, but I will do a detailed step by step in let's say in a couple of minutes, so don't worry about that. For now, I just want to see when the overwrite is going to happen. So let's continue these continue. We will do a deep dive into this, or at least look at them. So continue. I'm gonna jump over this. Okay, the pointers have not been overwritten yet. Okay, so now, okay, so great. So what happened is, as you can see here, because I jumped, by the way, over most of them, so we didn't get to see this. But actually what happened is the cookie got checked and it terminated. Let's do let's say a step-by-step check into this and look at what will happen in a normal situation and what will happen when our cookie gets overwritten. So we know 50 bytes will overwrite the cookie, by the way, and interrupt 29. This one is, if you Google it, this one will lead to it's an interrupt which will lead to an internally implementation. If I will add that also to the video, which will call the fast fail function, and this one will actually terminate the process immediately. Okay, so that's why the process will get terminated. So if I do Shift F9, you'll see that the process is going to terminate, and you see the exit code gave some exit number, some error code. Okay, why? Because the application did not exit properly. Let's see what will happen when we exit the application normally. So let's do, instead of this, just put 16, because our stack, if we go back to the code, we were copying 16 bytes. So let's say our normal case, everything is working properly. Let's run this. And so, okay, so now if we run this and let's start. Okay, push. I'm also gonna, by the way, jump over things just to speed things up, but then again, I will do a deep dive into all of these. At least we'll go through them step by step. For now, I just want to see that everything, if run successfully, no problems. Unable to process the exception. So did we? What happened here? Okay, so let's check actually my code. Let's send less than that's maybe 10 pattern, and the buffer here equals the pattern. Okay, so let's run. The length is 10 this time. And yeah, so this time we should, and okay, just double click. Yep, let's go. So if we start this time, I'm just gonna continue. Okay, good. Okay. Yep, I think everything see, everything here finished successfully, and that's why the exit code was 0. Again, return 0. So everything finished successfully. So that's why there was no errors in this case, right? There was no errors in this case. Now let's look at everything in detail and look at the how this is gonna work. But before we do that, by the way, one important thing here is let's put breakpoints out our main function. So that's why I installed here the demo copy of IDA. So just load your exe here, and I just want to find the main function. So if we look at this is probably where the cookies, yeah, see, this is where, by the way, the cookies get, and the exception handler, this is where the cookies and the exception handlers get registered and added to the stack. Also, as you can see here, this is where the exception handler, it's stored in EAX, and some operations are done on EAX, and then that is going to be stored into the segment register at 0, which is where our exception handlers are located. So that's why over here you can when we dump the or when we go to FS0, we can see where the exception handlers start. And this is where the security cookie checked. So these are a couple of routines probably. So these are all of these routines. So these are, by the way, I think the cookie, I'm not going to go in details about the cookie, but it is a random value. But anyway, for here, what we want to do is two things. So let's find the address of this. And the good thing is we have a static address. So I want to just put a breakpoint at 1040. So when I load my program, let's increase this, make it this one, I mean, make it 50 to do make an overwrite the cookie. Okay. Or actually, let's leave it 10 just to see the cookie first and then see it how it's going to be modified. Or should we do it modified? Yeah, let's go with this way. No problem. So let's do this and run it. And then go to address. What is the address again? 1040. Okay. So we need to go to address 45 1040. Let's go here. So this is where by the way, the cookie is being added, security cookie. So let's add an address here. And if by the way, by the time you watch this video, if there's anything wrong with this approach, please let me know. At the end, I'm also doing these videos so I don't forget what I have in my head, kind of. So that's one. And then the other thing I want to use either for here is also to find the main function. So main also starts at 10E0. So this is where main starts, right? Let's double check here. Yeah, this is 1040 and then main is at 10E0. So this is where main is starting. And okay. What do we have here? Call to this. What is this gonna do? Do a lot of other things. So main, just want to check. I have this. Exception handled in main. Call this function, which is our code, which is the print message, right? Let's actually just double check it, this one quickly. So what do we have here? This is the okay, the printing, the printf. Okay, yeah. So this is where the printf is happening, and okay, so this is printf. What else do we have here? Okay, just checking the couple of different things. I just want to make sure. So yeah, this is main, which we want, okay, to have, and then just checking different details. Okay, yeah. Anyway, by the way, I hope I didn't confuse you with this. Just the important thing for now, because we'll use the debugger, is to find main. So we know main is at 10E0. And by the way, it will continue to be at 10E0. Why? Because I will show you in a minute. Just let me put a breakpoint and then I will show you. So if we go to 10E0, okay, yep, this is where main is gonna start. Okay. So if I go back to my code and compiler, and just a reminder why this is always going to be the same, we go to the linker, we go to advanced, you can see dynamic base has been disabled. So we disabled, or there is no dynamic base, and we already specified where the base address is. So that's why it will always start at the addresses 4455 and then relative offsets for everything else. So good. And again, the idea here was doing this just for demonstration purposes. So what else do we need to do to get this started? Let's just start then. So if we, okay, so now we started the application. Okay, I'm gonna continue doing the, okay, return, okay, jump to here, push 14. Okay, if I run the code, by the way, we should stop at, yep, our uh, we are now at the main entry of our application. So if we now push EBP, you should see EBP has been added. Okay, let's continue, push these, initialization, other different stuff. I'm not gonna deal with them for now. And here, and now, before I do this, by the way, let's look at the Mona SEH chain. Okay, so if we do that, we can see that this has been registered or added to the stack, probably from a previous instruction. And now we can see that EAX, which has this entry, by the way, is for our one of our exceptions, 19FF0, 19FF18. So we look at 19FF18. This is where it's pointing. Let's see where this is going to be pushed to. Okay. So now, see what happened is at this address, we use the address and we added the pointer to the next SEH, which we already saw in the logs. So in the logs, we saw the address was 19FF60. So if we look back here, we can see at EAX, which has 19FF18, so it was pointing 19FF18. What is that again? Yeah, here. And what we added into that is the next pointer is at 19FF60, and then the handler is at 44, 55, 11, 55, similar to what we saw where in Mona here. So 44, 55, 11, 55. So we saw here how this value actually got added to the stack now. So we now saw how this value got added even to the stack. So we managed to see that. Let's continue now. So if we continue, let's see here. Oh, so we now arrived, by the way, 1040. You remember where 1040 is? So 1040, if we just go back here, it's where our cookies are dealing with. So let's pay attention to this one. By the way, and I highly recommend you use maybe like a pen and paper to write things down, or I will just write them here on a notepad. Let's see what we have. So if we look at, let's see here. So did we start? Yeah, push EBP. EBP is now added to the stack, which was, where is it? Yeah, this one. So let's copy this just to check. EBP equals this. And then let's continue our execution. So F7, push -2. So -2 is going to be added to the stack again. Also, we can see that here. So -2 here, and then push this value 44, 55 to 4D0. So we're going to push that. So let's take a copy of this, by the way. Let's take a copy of this and you'll see why. So this is 1, and then continue. Take a copy of this also. Okay. One thing, if I go back, by the way, to the Microsoft documentation, this is really the buff, like the stack is not really one. It's like it's an offset to, if I remember correctly, I really don't know where I read this, but it's an offset to a kind of, let's say, a whole structure. Okay, so probably this is the structure. For example, the following state declares yes buffers. Okay, no, not this one. Yeah, I don't know where I found that, but I think I can probably, if I found it somewhere else. And so where did I find? Mm, yeah, let's. I don't remember where I read that, but it's probably not just one value. So let's check again. We'll see that. So now we are gonna add another. See here, we are gonna add whatever is pointing now here. So let's see what's pointing now at our first entry of the chain. So if we do this before we continue, just to see, have an idea. So we see that our first entry is 19FF. So let's copy this. Oh, it's 19FF. Did I copy that, by the way? No, I didn't. I don't think so. Okay. Whole line. Yeah. So this value is going to be copied where? Into EAX. Okay. And this address, let's call it of first start of SEH chain, right? This is where it's located now. Let's save these notes to desktop, and let's call it SEH by cookie bypass. Okay, and if we go back here to our execution, so this value which we saw is going to now be stored into EAX. So let's continue. So it's what was it? 19FF18. So it got stored into EAX. Now EAX is going to be pushed onto the stack. So it got pushed on the stack. Let's continue here. These are all the different kind of initialization stuff. I'm going to continue because this is not really what we need. So here is what's happening, by the way, is the copy. By the way, this is the copy. So we saw how the stack got initialized, by the way, with that value, okay, with the stack cookie. And now we are writing these values onto the stack. Okay, we are copying the values here in our code, the A's. Where is it? The 10 A's. We are now they are getting copied where? Onto the stack. So that's this operation is, see, this one is copying. See here, there's a 41 getting copied. So this we copied now 8 41s, and you can put, by the way, a breakpoint at this entry and then just hit F9 if you don't want to. Especially with 10 it's fine, but later on if you are copying more than 10 bytes, it's going to take a while to do that. So now the copy should be over. Good, so that's why we finished. Now we are here, so we should get this message saying you entered. Let's finish. So the argument one, now we are gonna call, this is the print function really, so I'm gonna bypass it. So I'm just gonna, I'm gonna jump over it, so I'm not gonna do that. But if you look here, now we got the print message. Okay, all good. So now we should finish and go back to the previous function, or the one who called us. So if we continue here, so let's do all of this. Okay, good. Now look at this value. So look here at this address. Look here at this address. Let's go follow and dump. Okay. So if you look at this address here, not this one, sorry. So ECX, let's go to ECX. Let's follow the one in ECX, much better. And copy. Go to yep. So if we go to the address here, exactly. So if we go to the address here, what is the value that we have? We have, let's copy it actually. Let's copy it and let's bring it over here. Okay, so this is in Little Endian. Don't forget that. So we have 4F, right? We have D9, and then we have 10, and then we have 6, 8, right? This is what the value, this is in Little Endian. Okay, so 4F, so at this location, we have this value, and we are comparing it with ECX. So let's look at ECX, which is the one actually which is holding our cookie value. It got pushed into ECX. I think from previous instruction, probably I missed that, but we'll see it in another when I'm gonna do the follow up again. So look at ECX. What value do we have in ECX? So if let me just delete this and say at this location we have this, right? And then here, let's do ECX. ECX, we have, let's just do that. And then, are they the same value? The answer is yes. So this means the cookie was not overwritten. So this was the cookie, by the way. This was the cookie that is currently, that was currently added to the stack. So let's continue. So everything looks good. And then see, we are gonna finish the execution and jump here, everything, because everything went successful. And we are gonna return from here, and then we are cleaning the stack, and we will be ending our program. So I'm gonna just continue, return. I'm actually now gonna jump over these things just to reach the end of the program. And then the program will terminate, but the exit code is what? 0. Why? Because there was no problem in executing the program. Now let's modify it and overwrite our stack cookie and see what's going to happen. Okay, let's modify it, see what the stack cookie is gets modified. So let's close this. And this time, so this was for case number test 1. Let's bring this down. Okay, so you see this is, by the way, where we, yeah, I don't remember which one exactly we overwrote the stack, but these were all our entries. Let's go do a test again. Hopefully, if you continue, if you also do this by yourself and repeat the process, you will understand what I'm doing here. So let's run it again. Let's follow. Hope if you didn't follow in the previous one, you'll follow now, and you'll see how our stack cookie is gonna be overwritten this time. So F7, let's continue the execution. And if we now look at our chain, Mona SEH chain, let's see. So we should have the default ones, good, because we still have not, okay, added the one that comes from the program yet. So let's now continue. This is where we continue. Yep, this is where we will probably start adding our so this is where we will be adding our chain. Let's just check again. Yep, not added yet. So let's go back. So this is where our first entry will be here, and then we are gonna push the first entry of the chain where into the segment here. So what the segment is currently pointing will be pushed onto the stack. So let's do that, which is FFCC, which is the end of the chain, by the way. We just go back here, the end of the chain, see this one, and it's going to be pointing to our next one, which at the end also points to the end of the chain, which I mean it's our end, last one in our stack, in our SEH chain, I mean, sorry. So let's continue. All of these are good, good, good. And let's see. Hopefully I didn't jump over the one where we will add our handler. Until now, no. So all good over here. Yep, this is where EAX has the handler. So this is where the handler was added, by the way. So EAX 19FF60, this is where our chain now starts. So Mona SEH chain. Let's do that again. Hopefully I'm not jumping over things for you. So what did we have here again? So we had FF60, okay, and this one was added to, yep, the entry. So 19FF60. So if I go to Mona again, 19FF60 is where our entry now starts. So the thread environment block now at this location points here, which is exactly what we saw. Okay, again, I hope I'm not rushing into stuff. So the address here, this was good. Now let's do the call to our our function, which is going to do the copy. So this is, by the way, where we will be doing the copy. So let's go there. So this is the function that will be doing the copy. So let's do these, and now, okay, I'm gonna jump over this. I don't want to go into it. I will continue over here. Okay, and continue. These are not important, at least for now. I think I probably, okay, yeah. So let's see, what do we have here before I just hit continue. These are all good. Okay. 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 I'm not, by the way, debugging every single step, but I want to reach our how to step try to bypass. Did I jump over something, by the way? What happened here? We sent the let me restart this, by the way. Our code was sending, so if let me just check. So now we arrived at our main program. This is the main, and by now our chain is not loaded, or it is actually, yes, actually it is loaded. It got, is this main? I think it is, yeah. 10E0, if I remember correctly. This was main, yeah, 10E0. So probably I missed one thing. Okay, no problem. Let's just continue here. These values. So this one is going to be stored at EAX, which is where our pointer. So currently our next SEH is at 19FF60. So this value is going to be stored in EAX now. So 19FF60. Now we are pushing EAX on the stack again, doing these operations. Okay, okay. All good. So this is where we put the values into ECX. So ECX now holds our A's. Now we're going to do the call to do the copy. So this one is the one that's going to do the copy. And let's do, so the here we are initializing, by the way, we are initializing the stack cookie here, and these values, I think these are the ones. What is the execution now, by the way? That here, so the EAX, okay, so FF18 is where our next instruction got pushed into, copied to EAX. Okay, now we are pushing EAX on the stack to know where our exception handler is. Okay, this value got copied to EAX, so this value at this location, by the way. So if we follow, this is, if you remember, let's copy this value, these 4 bytes. So if you copy these 4 bytes, okay, so they are 21, 3, 3D, 50, 6B. Okay, so it's this value in EAX. Okay, let's continue. So now if we continue here, continue, okay, now we start, okay, copy this value back to the entry point of our chain, or our chain EAX. So 19 FEE8, 19 FEE8, 19 FE, 19 FE, yeah, this one. So this value is now gonna be put at the beginning of the chain. So let's look at the beginning of the chain now again, just to double check. We should see that. So yeah, 19 FEE8, now it's at the beginning of the chain. So as you can see, these, by the way, structured exception handler, these handlers get dynamically added to the stack as they are used, or as they are going to be needed. So now if we continue, and this is continue, okay, and this, we are gonna move one value from ECX, so we're gonna here move, I mean copy, by the way, copy 1 byte from ECX, which is the A's, into AL. So if we look at that now, we copied that into AL, and now the AL is gonna be copied into this location. So this is where we started now, by the way, to do the copy operation. Okay, so since this is the copy operation and we have 50 bytes, I'm not going to go over all of them. So what I will do is I'm going to add a breakpoint here and hit run. So now we are at the breakpoint. I can remove it. So we copied the 50 bytes. Okay, and now if we continue, push EAX, push this value, and I'm gonna jump the print function. So the print was successful, okay? But now when the function wants to unwind and go back, this is where things get interesting, because now we are gonna check the cookie. So jump, okay. Now we are gonna do copy -2 to this location, EBP -4. So we copied that over here. So you can see EBP. EBP is pointing at FEF8. FE FEF8, right? And we said at -4. So at -4, we copied the -2 value there. So now it's -2. And now what we are going to be doing is copying EBP -10 to ECX. So look at ECX now. ECX now is these 41s. And this is, by the way, where our stack cookie is supposed to be. So let's continue. And now we are going to put this into the beginning of the chain. So this is where we are adding, actually. So this is, by the way, not the cookie. This is where we are adding the, sorry, not the cookie. Yeah. This is where we are adding the pointer to the next instruction handler. right, to the beginning of our chain. So you can see the pointer. Now it's going to be added to the chain. So if we continue, and now if we check the chain, by the way, again, we should see that it has been now overwritten. Yeah, we can see that the address has been overwritten. Why? Because we overwrote it with the C's, with the A's, I mean, sorry. Let's continue, pop these values. Okay, okay. EBP minus 1C, that's going to be copied into ECX. So good, I'll do this. This is, now let's do this function and see the value again. So it seems the previous value that we did, the previous instruction, is where we load the value from the stack into ECX, and now we are going to compare it. So if we go to 44, 55, 3004, which I think we are already there, yep, here, we are going to compare this value with the value in ECX. We are going to compare this value with the value in ECX, okay? So if we compare now the value here, what's gonna, the comparison is false for sure. So we are now gonna be actually, I'm gonna jump this just to, so we are now at the interrupt 929 because this, the system will terminate the application. Why? Because the cookie got overwritten. And by the way, the cookie is usually added before the SEH, okay, before the next SEH. So if you look at the stack, you'll see the buffer, and then you'll see the next 4 bytes are for the cookie, and then you'll see the next SEH, and then so on and so forth. So if now we hit Shift F9, our application, did I hit Shift F9? Yeah, so if I hit now Shift F9, oh, it's running still. Okay, so there's no problem, and probably yeah, it's not able to proceed. Yep, it terminated actually. Yeah, yeah. I think there was a delay in my system is getting slow. So the application terminated. Why? Because the cookies was overwritten. Let's just repeat the process again, by the way, just one more final time, and just to make sure you got the idea here. So if we do a 5 again for this one. Okay. So if we start, let's start our work. Okay. So this is where we are actually copying this value to ECX. So this value is being copied to ECX. Okay, so let's remember this value, I think. Let's copy it just to check it out. And now let's continue the execution. Okay, okay, jump here. All of these are all good. Okay, so those are all to check the values that we have. We can see our pointer to the next SEH has already been added. So that's good. And let's just check it out, the chain. So Mona SEH chain. I think I forgot something. Yeah, SEH chain. Okay, so the value 19 FF60. So we have, this is where it is, 19 FF60. Okay, let's continue. So this one is now going to do the call to our uh, function. So let's go there. So if we continue here, I'm gonna jump over this one, by the way. Don't want to go in there, but at least, okay, you come back here. Okay, okay. All of these are good, good. Okay, probably these are the code that's actually doing the cookie thing. Maybe I didn't check. I kind of jumped into it. Let's do okay. All of these are good. Okay. Still good. I want to see where is our code. Oh, we got into this problem again. Okay, let me do this. I think I have to. Okay, so let's actually. So if I just want to this time see this value is actually even every time it's getting changed. And I think this is the value, by the way, of the cookie. I think it is. So let's just continue. I will jump over this. Okay, return back here. These are where the exceptions got added. Okay, and here I think this is where the exceptions get added. I'm gonna jump over this one this time. Okay, now this is where we do the this is where we do what? Let's go here. So if I hit F9, we reach the main function, which is what I want. Good. So these got added to the stack. The pointer to the next SEH got added. Okay. So now let's check here. This value over here is going to be added -2. This value here is going to also be added to the stack. So all of these are added to the stack. This value is going to be pushed into ECX, which is where our current SEH starts. So our current chain starts at F 19FF60. That's going to be added to EAX. Good. Pushed onto the stack again. Now we are creating this space over here. Push EBX, push ECI, EDI. Let's just move. Okay. So this value here at this location. So if we follow this location into memory address, and if we follow it, let's just copy these values here. So if we copy, okay, and it's actually exactly the one I knew it was the one. So you can see A6, F8, and then we have 09, and then C8. This is the cookie, the one that was pushed on. Okay, so now it's going to be copied to EAX. Probably some operation is going to happen with it. So it's copied there. Now EAX is going to be XORed with this value at EBP -8. Okay, now XORed with EBP. Now it's going to be pushed back to the stack. Okay, so so this value here is now pushed back to the stack. Let's just copy it over here. I just want to keep this. Again, I'm not checking, by the way, how the cookie is generated. I don't really care about that for now, but just to understand this. And here we can see the value in this is now actually pointing to our so now the handler, okay, now 19FF18 is going to be pushed at the beginning of our chain. So now if we check the chain again, we should see 19FF18, the starting point of it. As you can see here, 19FF18. Good. So let's continue. And then we do these, continue. This one is going to do the call for the copy. So let's do that. See, yep, this is the call for the copy. What's going to happen here is that it's going to store save EBP to make sure when it rewinds, does a check. So EBP got stored. The cookie, I mean, this is where we are now entering another function. So EBP, this value is going to be pushed. Okay. And now push this value onto the stack 44, 55, 24, D0. This one also pushed onto the stack, and then push EAX. Yeah, this push EAX now onto the stack. Okay, create some space. Okay, so we created some space, and what do we have next is, okay, we created some space. Now that value at that location is going to be copied into it's going to be copied into EAX, right? Yeah, into EAX. So it's copied there. Now some XOR operation. These are all added. I'm just continuing, by the way, here. Okay, okay. Okay, now we are going to be, this is where we are going to be starting the copy operation. So we can see, by the way, our next SEH is here, right? We can see our handler is here, right? So I'm assuming this one is our cookie, by the way. Let's just save that. Did I copy it? Yeah, let's copy this over here. Yep, I assume probably this is the one. Okay, so let's continue here. F7, now copying 1 byte. And now that 1 byte is gonna be checked if we finished. So I'm gonna put, because it's a byte by byte operation, I'm gonna put a breakpoint here, run the program, so it will do all the copies. Did I reach the break? Oh, sorry, I put the breakpoint on the wrong location. I put the breakpoint here. If I run the application with F9 now, it should, so here like you can see, this is where our pointer is, and this is where our yeah, this is where our pointer to the next one, etc. So if now I hit F9, we can see this value here. I want to, by the way, just copy this value also, just in case it's actually being stored at this location. Okay, so if I hit the F9 now, these will all be overwritten with the buffer because we have 50 bytes. So F9 got overwritten exactly. Great. Now if we continue, so do this, do this. This is the print message, so I'm gonna jump over it. Okay, step over. But we still get the message. But now when we want to go back to the previous caller, which was main, we will start doing our checks. So we are gonna do the check. So continue. I am gonna do the continue. So -2 is gonna be copied at that location. That value over here minus EBP -10. So EBP is at FEF8, FEF8, and then -10 is going to copy those values into ECX. Okay, let's do that. Continue. Push. Okay, okay. Continue here. I'm going to do the call, actually, jump into it, because we want to check this is where the cookie gets checked. So ECX now has this value, right? This value is in ECX, and it's going to be compared with the value at 3000 for 3004. So this value, was it any one of these, by the way? And I think there was some calculation that got, So it's not really directly done, probably. Or I missed a step, by the way. I could have missed a step. But anyway, this is the cookie, which is going to be checked, right? So it's going to be checked. And now we can see that it's telling us push EBP. So we're going to jump into another call routine, by the way. And I'm going to bypass this. Okay. Okay. Okay, and now we are going to actually do the call to interrupt 29. And as I said, interrupt 29, I will add the link to it. It's a fast fail, and interrupt 29, whether the architecture is x86 or x64, it's going to be first the value of it is be loaded into ECX. So we saw the value number 2, which is going to call this function, this interrupt was 2, and then it's popped into ECX. So the location of the code argument is always in ECX. On an x64-bit system, it's going to be in RCX. And on ARM machine and ARM64 is going to be in R0 and X0. Again, I'm just reading this from the Microsoft's website. So now if we try to continue, we can't because the interrupt has happened. If we hit Shift F9, the application should terminate with the code that the application terminated. So we can see that if we had overwritten our code, even if our code, our exploit was successful, by the way, without triggering in SEH, the cookie will actually tamper our exploitation process. So what we will be doing this time is because we saw if we overwrite them, then the cookie will prevent us from running the application and then probably terminate our shellcode. But SEH is one way to bypass the cookie. So what we will be doing now is we will be using the SEH method, which we've already done, to bypass the cookie. So all we need to do here actually is, I think this should be fine, by the way, but let's now double check. So buffer, shellcode, and I think this address is no longer this one. So let's just run it to get some addresses, by the way, because the addresses are now different. Everything else should be the same except the offset. We saw it's 32 now instead of so we have 28 bytes, and then we have the 4 bytes for the next SEH and so on. So let's just continue, but this time I just want to get an address. And yeah, so if I go to Mona SEH, okay, we can do that. Wait a little bit, not gonna take too much time. Okay, so if we go to SEH, we can take one of these addresses over here and just use them. So if we use, for example, this one, so 1545, I'm going to use this one, 1545. Okay, so if I go back, close this, and go back here, so if we do, yeah, here it is. I've already probably done that from a test. Okay, and this is from the previous video that when we didn't have the stack guard like enabled. So we can now get rid of this, or actually, why did I do that? Let me just do this, right? And do number 3. So this is number 3. And let's do this. Okay, let's remove this also, we don't need it anymore. And now let's run our code. Let's copy this address, by the way, I will need it to put a breakpoint on it. Okay, and good. So let's go to this address here, add a breakpoint for our. Okay, so if we hit F9, we are at the main function, right? We are at the main function. And now if we let's continue a little bit. Let's just do a couple of the instructions here. So this is where we are in the one that will do the copy, right? Yep, this is the one that will do the copy. Got initialized with the cookie also, and now we are copying the 1 byte at a time. See, 1 byte at a time. So I'm gonna put a breakpoint. Actually, it's still here. So I'm just gonna hit F9. We finished the copy, all of those, and even the pointer to next SEH. We finished overwriting all of this with the shell code and everything else. All is done properly as we want. So now we can continue our execution, right? Oh, we got an exception. Great. So we triggered an exception. And if we check the chain, Mona SEH chain, and if we check the chain, we can see that the chain has been overwritten. So this is where it starts. It's overwritten with this value. And yeah, so let me do just want to check one thing. No, not one. Here I want to check. Yeah, okay, good. So let me just do this. So now what we need to do is shift F9. We should stop at our exactly. So shift F9, what happened is the value in our SEH chain, right? Where our next SEH is located. This is again, we saw it in Mona. If I go back here, where is it? Let me just type it again. SEH chain, okay. So if we look again here, what am I looking? Yep. We look again here. Yep, this one. We can see it was the handler is at 4455. So we are now calling actually this one. So we are calling it, okay. But since, excuse me, there is nothing there to be done, we are gonna now do the pop-up return. So we will pop these 4 bytes. So this is, if there was a handler, this is where the code for the handler will start. But since there is no really handler, we fool the application and the system. We are gonna now use the return to this address. So the return to this address, if we follow in dump, what is it? It's our jump instruction. So once we do the return, this value is going to be loaded into EIP. So F7 loaded into EIP. We went to the jump instruction, and now the jump instruction is going to go to FEF2. So FEF2 is immediately at here. So we are going to jump all these values over here. So see, now we are at FEF2. And now if we continue, hit our F9, by the way, our application continued and we got our shell code. So we bypassed the security guard cookie. It didn't even check that. Why? Because when we triggered an exception, we had to follow the exception routine. And since we, I mean, the exception handler routine, but since the exception handler routine is really not a routine, there is no handler there. There were just addresses mangling how to jump around in memory. We managed to bypass that and not continue unwinding the process and going back to the previous function. So that did not happen. And this time we managed to run our payload. Okay, so that's it for this video. I hope you saw how those cookies get added to the application. They are again usually at before the next instruction exception handler. Uh, but again, you can trace them and see how they are getting compared, where they are getting compared, and based on that, interrupt 29 is going to be called, especially on an Intel architecture, whether 64 or 32. But otherwise, like you saw, we bypassed the application. We did not have to. Uh, we managed to bypass the security guard. So if I let me, by the way, just before I end the video, let me just do the one final thing here. Call this, save it as bypass 4, and then let's delete this. We don't need it, and see run it without the debugger. Okay, so all good now, and let's check if everything is working correctly. So if we run this, we should get our application and get our calculator. So we managed to run our shellcode. Seems I've added 4 bytes extra. So we managed to run our shellcode and bypass the stack guard protection, which SEH is actually, SEH exploits are known for bypassing stack guard protection. If you have any questions, or if you want me to go and let's say explain anything else related to this, please let me know. Otherwise, I will continue on another example on SEH, because this time the buffer was immediately after uh, our handler. So we uh, we called the handler. The handler actually was just a pop-up return, and then the pop-up return did not do anything, but we now call the next SEH, and the next SEH just did a jump to the location after those handlers. But in this case, we had space in the area behind that, so we were able to exploit it. But what if your area is actually before that? How are you going to deal with that? So we need to go backwards. So we're going to be dealing with negative offset. So that's what we will be discussing in other videos. And sometimes you might need to do multiple jumps. So also keep that in mind. We might need to do multiple jumps, and I hope I will find an example to see how those will all play off. Okay, so that's it for this video. I hope you learned something, and see you in the next one. Thank you, and bye-bye.